Hello everyone. Today we're going to talk about speech emotional reduction using deep learning. First, we'll see what is speech reduction. See, emotional reduction is the process of identifying human emotion from the speech signal using artificial intelligence and machine learning technique. Just example, like by the hearing my voice only, you can tell I'm nervous or excited. By unconsciously, you can recognize. So what we are giving the superpower to computer. So So it's like your voice is like emotional fingerprint. When you are angry, your vocal would be tight and current pitch would be high and intensity. When you are peace, your vocal would be smooth and your voice would be bit kind of smooth. So using that technique, we're going to direct the speech and emotion. So we have like 8 types of emotional kind like happy, sad, angry, neutral, and then a few deductions. And then why it's important, we can use this like many fields like customer care service, medical and virtual assistant and entertainment gaming industry. It's like kind of a like speech virtual assistant sucks. Example, Alexa and the Google assistant is like if you ask something, it will give something else. And then how does the speech work? It's a where it getting interesting. Hmm. It's like kind of 5 step process. Like speech accusation. Speech accusation is like when we capture the audio, just like recording the voice message. But we have a specific techniques like the audio should be clear, and then it doesn't need any background noises. Like we have like kind of set of techniques for that. So we'll record according to the techniques, and then once we finish the recorded and we'll go to the pre-processing. In the pre-processing is a where we clean the data and audio by removing the background noise and normalization the volume and cut unwanted noises. We'll just trim the silence. And then once we did everything, we'll just extract the feature extraction like by the pitch, tone, intensity. We are using MFCCS. It's kind of mathematical functions. Once we done everything, we'll use a machine learning model like SVM, CNN on RNN processors using LSTM. Once we did, we'll classify the machine learning model. We will give the results like I was happy or sad, angry based on the pattern. Once we done everything, we'll get the result. And then how it will detect the feature. For example, you can see in the slide like the pitch. If I was angry, my pitch volume will be high and variation. If I was sad, my pitch would be low and it would be a bit stable. It's like kind of same everything. For example, if I was happy, my volume would be energy and my tone, everything would be bright. For neutral, it would be stable, moderate. And then the pipeline, the audio pipeline is like it is kind of same process. We are just giving the inputs. It's audio file. Once we did the audible, we'll do the volume normalization. Once we did audio normalization, we'll trim the silence. The silence means in the starting 10 minutes, like some people, if you're taking the video like first 3 4 minutes it would be silence or something, so we'll just trim unwanted part and we'll reduce the noise reduction. Once we done everything, we'll do the feature extraction and then we'll do data augmentation. We'll just use or add the audio noise and we'll just shift the pitch. We'll just stretch the timing and volume. From here, my friend will continue.
Let's talk about the neural architecture. So our initial model was a simple two-layer LSTM model. It performed decently with around 77% validation accuracy. However, we proposed an enhanced hybrid model with CNN plus by LSTM and attention model. This significantly boosts the accuracy and captures both local and temporal patterns. Uh, so next, talking about the data set we used, it's a Surma D data analysis, which has a variety of audio files, which also audio files and the emotion labeled to it. So this data set contains like files for angry, happy, sad, fear, disgust, and neutral. So these are the performance related metrics which we got. So after training for After training for 340 epochs, our model achieved 80% training and 77% validation accuracy. The training validation gap is low, indicating no significant overfitting. So we plan to apply early stopping and attention mechanism for further improvements. Next, looking at class-wise performance. Class-wise performance. Uh, Happy had the highest accuracy, which is around 85%. Discussed was the toughest with just 70% accuracy. Most emotion over between 75 to 80%. This helps us identify which emotion need better representation for feature engineering. And so controversial applications are AI judges in control courtrooms, or personal advertising, or gaming, or AI dating assistants, and car safety systems, and virtual assistants, where we can integrate this technology to understand human emotions better with just voice. So, some of the technical issues that we faced during implementing this project was memory management, as the data was too big, and the RAM was and the memory was very much limited. The terminal crashed multiple times, and we couldn't handle some issues with emotions like sarcasm and multiple other emotions too. So, production deployment, this is the end-to-end system architecture where the system records the audio input and pre-processes it, and features are extracted like MFCC, chroma shift, and there is Mel spectrum, etc. And then these features are given to the deep learning or machine learning model, and this looks for the patterns and gives you the result, which is sad, angry, happy, etc. So future research directions, advanced AI techniques, which includes AI transformer architecture, self-supervised learning, few short learning, which helps the model to work better for sarcastic voices, etc. And so this is the solid foundation for advanced SER research, where we went through some of the reference papers, which helped us perform much better. Thank you.